Today we're talking about rate of change, and we said that rate of change is another way to say slope. The biggest difference is that we include units because it's a rate. And so if you open up your foldable to the first example that we have here, it says the graph shows the height above ground of a rock climber over time. Find the rate of change. Then explain what it means. So first we have to determine what's happening in the graph. Is the climber going up or down? So as time goes on, their height of the rock climber above ground is getting less and less and less and less. So they're starting high, and then as time goes on, they're a little lower, a little lower, a little lower, a little lower. So this climber is going down. How does height change as time increases? Include direction up or down. So as height decreases, height decreases as time increases. This results in a negative slope. If one is getting smaller while the other is getting bigger, we have a negative slope. If they're both getting bigger, then we have a positive slope. So pick 2 points on the graph to use. We're going to pick 2 points to find our slope now. They gave us 1 point here and 1 point here, so I'm just going to use the 2 points that they gave us. I'm going to use 0.26 and 8.0 because I can be confident of those. They're already plotted and even labeled for me. And then it says find the slope and include units. Should it be positive or negative? Well, again, we know from left to right this graph is going down, and so this should be a negative slope. And we know that rise over run, in this case it's going down 26. And the way that I know down 26 is because it's at 0.26, so it's just above 25, but it's going down 26. And then our run is 8. It's going over 8. And so our rise is negative 26 over our run is 8. Notice here that it says include units. So it is negative 26 over 8, and it should be negative 26 represents my height, my meters, for every 8 minutes. And so I'm going to label those. Oh, I'm sorry, not minutes. The time is in seconds. That's why we use our axis labels to help us. So I apologize. I'm going to erase that, and I'm going to write in 8 seconds here. So we always want to reduce slope when we can. In this case, both can be divided by 2 because they're even, and so negative 26 divided by 2 is negative 13, and 8 divided by 2 is 4. I'm still going to include my labels here, negative 13 meters for every 4 seconds. And then the last thing here says write the rate of change as a unit rate and then explain what it means. In order to find a unit rate, we always just divide. So I'm going to put a little division symbol here. We just divide our fraction. 13 divided by 4. And again, if you have a calculator handy, you'll want to pull that out. 13 divided by 4 is negative 3 and 25 meters per 1 second. So what happened here is we divided bottom by 4 and we divided top by 4. 4 divided by 4 is 1, and negative 13 divided by 4 is negative 3 and 25 My labels stayed the same, and so what this says is that the climber goes down 3 and 25 meters every 1 second. That's what our unit rate is telling us here. So the last thing that it asks is a little review from previously. Does this graph show a proportional relationship? Explain. Remember, in order to be proportional, it has to go through, it has to be a straight line, which it is, and go through the origin. This line is not going through the origin, so this is not a proportional relationship. No the line does not go through the origin. So here we can start to see how all of these concepts are going to start to come together. We've got slope, we've got proportional relationships, and we're connecting them to real life situations and connecting them to past units like unit rate and trying to decide what this graph is showing. And so this is example 1, and example 2 we're going to do together in the next video, and it's going to be a little bit more in depth because they're going to give us a table and ask us to actually plot the points and make the graph ourselves. So we're going to go a little bit deeper in the next example.